In this video, we're going to be solving a compound interest equation. So here's our example. When you were born, your grandparents deposited $5,000 in a long-term investment in which the interest was compounded quarterly. On your 25th birthday, the value of the investment is $25,062.59. What is the annual interest rate for this investment? Well, we need to know what our compound interest equation is. So our compound interest equation is A equals P times 1 plus R over N raised to the NT power. Great. What do each of those variables mean? Well, our A is for balance. Our P is for principal. The T is for time. The N is for the compoundings per year. And our R is for our interest rate. So let's see what information our problem gave us. So it says your parents deposited $5,000 in a long-term investment on the day you were born. That sounds like the principal investment to me. So deposited $5,000. So principal investment was $5,000. It says on your 25th birthday, and they started on the day you were born, which means you had 25 years for that to grow. It says that the value of the investment on that day is $25,062.59, which would be the balance. And it says how many times a year it was compounded. And it said it was compounded quarterly. So think of a school year. How many quarters are in a school year? 4. There are also 4 quarters in a year. So a quarter would be 4. And it says, what is the annual interest rate? Which means that's what we don't know. That's what we're looking for. So R is just going to be an R. So let's go ahead and let's plug in all of our things into our equation. So we have $25,062.59 equals our principal, which was 5,000 times 1 plus our rate, which we don't know, divided by our N, so 4 times a year, and then we're going to raise that to the NT power. So again, our N was 4, and our T was 25, so we're going to multiply that by 25. Well, we know that 4 times 25 is 100, so we can go ahead and rewrite our exponent as 100. So we're trying to get our R by itself. So we're going to go ahead and we're going to divide both sides by 5,000 to get rid of that 5,000 out front. And when we divide $25,062.59 by $5,000, that's going to give us the value 5.012518. And we're going to set that equal to 1 plus R over. Then we want to get rid of that power of 100. So there's a couple things we can do here. We can take the 100th square root, which is kind of a lot, or we can raise each side to the reciprocal of that power. Oops, it should just be 100. So both sides will be raised to the 1 over 100 power, and doing that allows us to cancel those out. Then, if we take 5.012518 and we raise that to the 1 over 100th power, that is going to give us the value 1.016250002. It's kind of a lot to write down. We can probably simplify this down to the 625. So that's going to be approximately equal to 1 plus our R divided by 4. Then we're going to go ahead and we're going to subtract 1 from both sides, and that is going to leave us with 0.0 0.01625 is the approximate answer for our rate divided by 4. From here, we will multiply both sides by 4 to get rid of the 4, and that's going to tell us that R is going to give us the approximate answer of 0.065. Now, when we're thinking of how that converts to a rate, because when we're talking about banks and interest and loans, we talk about rates as percentages. So we need to convert this to a percent. So if we're going to convert this to a percent, that means that we will need to take our decimal and move it 2 times to the right, which will give us that the rate is approximately 6.5%. So we're able to say that the annual interest rate is 6.5%.